Welcome back, guys, to Remote Explorations. This is me, Sinjan. I'm a first year undergraduate student studying at IIM in Bhubaneswar. I'm trying to build a career in mathematics and also trying to mentor people and educate my juniors into focusing on a career with mathematics, which is very bright, a little tough, but bright. So, this is my 11th video for the channel, and as promised, I am just bringing up lecture series for ISI CMI crash course and other mathematical entrance examinations, of which my first chapter of polynomials, which consisted of four lectures, lecture 1, lecture 2, lecture 3, and lecture 4, have been successfully completed. I still haven't uploaded the worksheet, but I am thinking of uploading the worksheet once I'm done with number theory 2. I have uploaded all the four videos in my YouTube channel. Do go check it out. Now today, as promised, I had said I would either come up with number theory or with sequence and series, but I thought number theory is a more important chapter since subjective questions also ask for number theory. So let's start up with number theory. First of all, reference text. Let me talk about the reference texts. For one, again, Pathfinder. Number two is, as usual, my tomato. Number three is my CMI PYQ. That's my CMI tomato. Number four is your pre-college mathematics for greater depth and clarification of all concepts. Pre-college mathematics by New Age Publications. And number five is the probably the best book of number theory till date, which is my David M. Barton's Elementary Number Theory. Elementary Number Theory. This is my really good book. People who have done PhD in this topic have also refer this book. But yes, this book is a little high concept and it is probably one of the very handful of books which is completely like it has 500 pages and it is totally of number theory. So this is you need if you have completed all the prerequisites. So these top four are my prerequisites or at least Pathfinder and pre-college mathematics or not Pathfinder, I would say tomato, CMI and pre-college mathematics, and only then you should move on to David M. Barton since it is getting you into a total depth of the chapter. So now my content for this chapter, again I'll be taking 2 to 3 lectures, maybe 3 lectures for this. I will be doing it as a crash course. I am assuming that you guys at least know the basics and you have just come up here for revision. So I will just be going for revision. So I'll be covering this line topics. We'll be starting with divisibility today. Then we'll move on to Euclid's division lemma. Then comes GCD, which is the greatest common divisor or the HCF in your language. Then we'll also be showing you LCM, the least common multiple. Now we're coming up to primes. What are primes? Mergent primes, co-primes, twin primes, all types of primes will be covered. Some divisibility properties of the primes will also be covered. Some square related rules of primes will also be covered. Fundamental theorem of arithmetic comes now. Then comes my composites and properties, that is the number of factors of my composite numbers and those all very nominal properties. Then comes my residue system modulo n, that is my congruence. Then comes GIF function, that is greatest integer function, the box function, that is greatest integer lesser than or equal to something is known as the greatest integer function. And then comes my Diophantine equation, which is subjected to time. Since my Diophantine equation has not been asked in ISI, though it has been asked in CMI, but that even if you don't solve it through Diophantine equation, you can still solve it, though it will be a little bit lengthy. So today's first topic is my divisibility. So we all know what is divisibility. Very simple one. If A divides B, then my B has to be A into X for some X belonging to my reals. So if B is a number, suppose let me say B is 15 and my A divides B. So basically we know multiples of 15 are not multiple, I should say factors of 15 are 1, 3, 5 and 15. So basically if I want to give my A to be 3, then 15 is equals to 3 into something, so my X becomes 5 here. So basically B is 15, A is 3 and X is 5. This is my sign of divisibility, by the way. This is how we write B is divisible by A. And for not divisible, I will be just be simply slicing it down. This means B is not divisible by A. Next comes up some properties. One is the transitive property, the transitive relation property. That is, if A divides B and B divides C, that very directly means A divides C. My next property is if my A divides B and also A divides C, then A must divide B plus C, A must divide B minus C, and A must divide B into C. Number 3, if my A divides B and also my A divides B plus C, then my A divides C. These are some very general properties. We do not need to prove it, or maybe I can show you by proving any one. So first let me write down all the properties. Similarly goes for the subtraction case. If A divides B and my A divides B minus C, then my A has to divide C. Then comes up mine. If my A divides B and B also divides A, then A is equals to plus minus B, or B is equals to plus minus A. Next comes number 6. This is one theorem known as Bezout's theorem, which I will be showing you when I will be doing the primes, or probably just for a division algorithm. This theorem states that this is basically a theorem, but you can just learn it now as a property. I won't be showing you the proof, but I will be just doing 1 or 2 questions based on it. And by the way, guys, today's class is mostly going to be a theoretical class, and I'll be proving up some results, but I won't be practicing, like we won't be practicing any questions today. So if my A divides B and also my A divides C, that means my A must divide K1B plus K2C, or my A must divide K1B minus K2C, or my A must divide K1B into K2C. How? Now for all K1 comma K2 is an element of integers. So this is what my Bezout's theorem also says. like the my initial statement for Bezout's theorem. So if my A divides B and A divides C, so let me just give an example. This case needs an example, right guys? So my example is, for a better understanding, I'm just giving an example just to show that this result holds true. So my 3 divides 6 and my 3 divides 9. That means my 3 must divide K1B plus K2C. That means my 3 must divide 6K1 plus 9K2. One way is to prove is by taking some examples of K1 and K2, and the another way is to just show that it is a common factor of 3. So now my 6K1 plus 9K2 can be written as 3 into 2K1 plus 3K2. I have my 3, this is divisible by this 3, hence this full thing is divisible. One more condition, my number 7. A divides B if and only if. Like if only the my second condition is satisfied, then only my A will be dividing B. That is, if my second condition is satisfied, only then my first condition is going to be true. If and only if my MA divides MB for M not equals 0. This is my general results, and now some case-based results. So my case-based results. Number 1, x plus y divides x to the power 2n plus 1 plus y to the power 2n plus 1, subject to the condition that my n has to be an element of natural and x plus y can't be equal to 0. Okay, so basically if my powers of x and y are individually odd, then only my x to the power that odd power plus y to the power that odd power will be divisible by x plus y. That's what basically this case based result says. Next one is my x minus y divides x to the power n minus y to the power n for all n belonging to naturals, and my x minus y cannot be equal to 0. So this is true for all n. We'll be doing some questions. So these are in a nutshell all my properties of divisibility. Before going on further for divisibility, I will be just doing some basic properties of normal divisibility. The second, Yeah. So divisibility by certain numbers. It's very like important, and you need to keep it on your fingertips since very many MCQs can be solved by the like cutting out the unavailable or unfeasible options just by looking at the units digit or the divisibility rules. So moving on to some divisibility. Wow, this is a nice color. Divisibility by certain numbers. There's the flame one. Okay, so my number A is divisibility by 2. Simple rule, units digit must be 0, 2, 4, 6, 8. Next comes my number P, which is my divisibility by 3. Is basically my sum of the numbers, that is sum of the digits of the number given must be divisible by 3. Sum of the digits of the number must be divisible by 3. Changing the color, this looks a little bit odd to me. Sorry for this, guys. Shift W. That's my number 3, which is a divisibility by 4. Number formed by number, not by number, formed by last two digits must be either 0, that is my last two digits either must be 00, or must be divisible by 4 full. Next, my number D, which is your divisibility by 5. I'm giving up the pace, guys. Sorry for this. Divisibility by 5. Very easy. Last digit is 0 or 5. So number E is divisibility by 6. Number formed, number must be divisible by 2 and 3. Divisibility by 7. This is an interesting one. Only if you see it properly, then 7 and 11, the divisibility rules are interesting. Others are nominal. So my 7 is I have a number. What we do is steps. Remove the last digit and double it. Subtract it from the remaining number. Subtract it. The remaining number. Check if the result is divisible by 7. If yes, then stop. If no, then continue. My G is divisibility by 8. By 8. Number found by last 3 digits must be divisible by 8. For 4 it was 2. For 8 it is 3. By 8. Next divided by 9. Similar to rule of divided by 3. So my GH 30 by 3, sorry, by 9. Extremely sorry, guys. This is my some of the digits are divisible by 9. And divided by 10. The easiest one, divisibility by 10. Last digit must be 0. GHI. Next comes J. There is an interesting one again, like the number 7, not like that, but interesting as number 7. Divisibility by 7. Sorry. By 11. This is it, guys. Yeah. Divided by 7. Divisible by 11. So what do we do? Divisible by 11. This is 11. Okay, not 7. Sorry for my pronunciation. 2. This is 11. So it is basically sum of digits at even places. Which one is bigger? We just need to see which one is bigger. Minus sum of digits at odd places. If we get a number, now this should be either 0 or divisible by 11. Cool. Yeah. Now, time for two problems. Just to go through it once. The chat, just a second, guys. The time for question. What is my first question, Shay? It's a proof. Show that 1 to the power 1997 plus 2 to the power 1997 plus dot 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 plus 1996 to the power 1997 is divisible by 1997. So, yeah, this is my question. Looks very complex, doesn't it? 1 to the power 197 is chalo, it's 1. 2 to the power 197, big. Like even calculator won't be able to calculate it. That's where we come for properties. If you remember, I had just taught you my a plus b must divide a to the power some odd number plus b to the power some odd number. Here what we have 1 to the power 1997 plus 2 to the power 1997 plus dot 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 plus dot 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 plus 1996 to the power 1997. Cool. So I'll be grouping it. How? 1 to the power. I need my a plus b to be 1997, and also this is 1997 since this is basically my a plus b. So I need my this thing also to 1997, and for that I need to pair up this with this with this, and so on and so on. How? 1 to the power 1997 plus 1996 to the power 1997 is my one term. Let's analyze my first term, which is 1 to the power 1997 plus 1996 to the power 1997. So my, as I had said, a to the power some odd number plus b to the power, that same odd number is divisible by a plus b if and only if my a to the power is a odd number. So my powers of A and B are both 1997, and fortunately my A plus B is also 1997. So basically this thing is divisible by 1 plus 1996, that gives me 1997. Now next term, 2 to the power 1997 plus 1995 to the power 1997. This term is again divisible by 2 plus 1995 is equals to 1997. What do I have for my next term? My next term is 3 to the power 1997 plus 1994 to the power 1997. But this term is again divisible by 3 plus 1994, which is basically 1997. Hence, plus dot 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 dot, this whole thing goes in such a way that each term of the summation is divisible by 1997. That means if my each term of the summation, each single term of the summation is divisible by 1997, that means my whole summation has to be divisible by 1997. So hence, or probably since, each term is divisible by 1997, that's it. That's the question. That's how you use the properties. Now, let's take a look while I find some more questions. And here's some good questions. Probably. I today my focus won't be on questions, but still then I'm trying to get single question. No, unfortunately, no. I'll be checking two of my other books for another single question, like another good question for this. See, possibility, no questions based on only divisibility. So let's move to Euclid's division lemma. This is a very easy topic. Euclid's division lemma. This says that if my A and B are two integers where A not equals 0, then there exists unique integers Q and R such that my P equals to AQ plus R with my R belonging from 0. 0 must be closed since for completely divisible my remainder is always 0, 0 and mod A. This is open. Very simple one. The normal your division algorithm is only this. So one good question I got based on division algorithm. It goes like this. When the numbers, I am given two numbers, that one is 19,779 and 17,997 are divided by a certain three-digit number. Divided by a certain three-digit number. They leave the same remainder. What we need to find largest such divisor. Largest divisor. So my 3-digit number becomes my divisor. Largest divisor. Second is the remainder. and also largest search divisor and number of divisors possible, and number of divisors possible. Nice question, good one. And to solve it, so let my divisor be d, let divisor be d, and remainder be second. And remainder be r. Therefore, my 19,779 can be written as dq1 plus r. Similarly, my 17,997. So this is my 17,997 can be written as dq2 plus r. Now, if we subtract them, so my q1 and q2 are two different remainders. Extremely sorry for my slip of tongue. Two different quotient. R is my set of remainders, which is same, and D is my divisor, which is again same. So I subtract my equation 2 from equation 1. So this gives me 792,978,711. 1782 gives me basically your D into Q1 minus Q2. We know my D is a 3-digit divisor. Now my possible values of 3-digit divisor of 1782. 1782 if I divide it by 2, I am getting 891. If I divide it by 3, I am getting 594. If I divide it by 4, I am getting divisible by 4. So since it is divisible by 2 and 3, so it will be divisible by 6. 1782. So 297. If I divide it by 9, since my small digits is divisible by 9, again I will be getting it as 1. This is 7. 1782. So 9. 198. 162. Just a second again. Yeah. So now if I divide it by 11, since 8 plus 1, 9, 7 plus 2, 9, so that gives me 0 as shown in the divisibility rule, so that gives me 162. And now my largest, these are all my values of D possible. 891, 595, 590, sorry for this. 594, 297, 198 and 162. And I need to find my remainder from my highest divisor, so just will be remainder, right? I'll be dividing it by 891, so 891 must divide any one number, so either of the number it divides, my remainder comes out to be 177. So my answer is therefore T equals 891 and R equals 177. One question might come to your mind is, why am I subtracting this? I'm just subtracting this so that it becomes easier to get my D. Good. So we did two topics today. I think I'm having some issues. And everything is cool. Just a second. Yeah. These are all the things we did today. But let me just give a brief introduction of GCD. So what is my GCD? My GCD is basically the greatest common divisor of any two integers a comma b. At least one of them must be non-zero. That is the greatest among the integral divisors of a and b. Ways to find GCD, that is, one way is to just list out all the factors and find out the greatest common divisor, and another way is the successor division method, where we divide, where we continue. If I have two numbers, that is a and b, I first divide my b by a. That is, a divides b, I get a remainder, that remainder divides a, then again I get a remainder, the second remainder divides the first remainder, then again my third remainder divides the second remainder, and goes on and on until and unless it is not divisible further. Then we have some properties of GCD, where I am just telling you my agenda for next day, which is your day after tomorrow. The properties of GCD, a comma b, Bayes' theorem. I will be doing the properties of Bayes' theorem. Then comes my Euclidean theorem, whose proof I won't be doing, but I will be stating my statement, which is the number of ends infinite. It has a big proof. Then comes my Sophie-Germain identity, that is your factorization property, one very important question. Fundamental theorem of arithmetic, number of positive divisors of composite number. We'll be going on forward like this, no differential equations. So I'll be trying to wrap it up within 3 lectures. So my next day's lecture, which will be coming up on Monday, is going to be a little bit large. So yeah guys, that's it for today. Let me just revise up once more what I have done everything today. Content I had given this, we revised divisibility and discussed some properties, some case-based properties. Then came my numerical divisibility rules, that is divisibility by certain numbers. By 2, divided by 3, some of the divided by 4, divided by 5, divided by 6, divided by 7, 8, 9, 10, and 11. Then I did one good question. It most probably had come in some RMO before 2000, as far as I can remember. I think I thought I may be wrong. Do correct me if possible in the comment box. Then come the Euclid's division lemma. If A and B are two integers, this and this, then I did one nice question, a trickery one, not that much trick. So that's it for today, guys. The 11th video and my first in series of number theory. So goodbye for today. Do like, share, and subscribe. And you feel any kind of problem, any kind of suggestion, any kind of guidance, you already have my Instagram handle, my threads handle, my X's handle, and also I am available at my blog. Do subscribe, please, please, please follow my blog. It's an earnest request since we would be getting the notes and shortly DPP sets also there. So yeah, do like, share, and subscribe and refer it to your friends. Goodbye for today, guys.